Welcome to the AGWA Automated Geospatial Watershed Assessment Tool video series. AGWA was developed by the University of Arizona with the USDA ARS Southwest Watershed Research Center and the US EPA. AGWA is available at www.tucson.ars.ag.gov/agwa. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is the fourth video in this series, Discretize a Watershed. Watershed discretization breaks up the delineated watershed into model-specific hill slope elements. The size of the elements is determined by the user to capture variability of soils, land cover, and topography across the watershed. This image shows the Andreas Canyon watershed used for the mountain fire tutorial that's been discretized into the hill slope elements and channels. Watershed discretization also creates a stream feature class that drains the elements. To discretize a watershed, go to AGWA Tools, Discretization Options, Discretize Watershed. In the discretizer form that opens, select the delineation from the drop-down menu, Andreas Canyon / Andreas Canyon, that you created in the previous video. The next step is to select the model from the drop-down menu. There are several models available for use in AGWA. You can read about each one on the AGWA website. For the mountain fire tutorial, we'll select the Kinneros model. Next is the stream definition methodology, which defines at which point flow becomes channelized in the upland hill slope or plain elements. There are three options for defining stream initiation. The first is threshold-based, which is based on the number of cells for channelized flow to begin, known as the contributing or channel source area, the CSA. The existing stream network method allows you to use an existing stream network such as the NHD flow lines. The channel initiation points method uses a point theme that defines the channel starting points. For this tutorial, we'll use the threshold-based methodology. In the Stream Definition Methodology box, select Threshold-Based. In the next box, select CSA acres for the contributing source area in acres. The other threshold-based options are the CSA in hectares, the CSA based on flow accumulation, or the flow length in meters. In the threshold box, enter 140. This is the number of acres we'll use as the threshold for channel initiation. The next box, percent total watershed, should automatically read 2.49. 2.5% is the default percentage for the contributing source area in AGWA and is a good starting point. Varying this number will change the size of the upland plains and the entire discretization. Leave the Enforce CSA box unchecked. Checking this box will force all hill slope elements in the watershed to be 140 acres, or about 2.49% of the total watershed area. The internal pour points methodology allows you to incorporate important hydrologic features into the watershed representation for management or monitoring, such as stream gauges or erosion control dams. There are three options for selecting internal pour points. The default method, which is to not use any internal pour points. The point theme, which is used to create pour points at specific locations, such as an erosion control dam or stream gauge. Or the user-defined method, which allows you to manually click on the stream network to identify pour points. In the Select Theme box, select the VARS point theme. Select the ID field from the drop-down menu, ID. Next, click the Select Feature button and draw a rectangle around the points for the stream gauge and Forest Service boundary VARs, the two left points. The far right point is the road culvert, the watershed outlet. Leave the snapping distance at 0. and name your discretization CSA underscore acres 140 underscore VARS underscore 0M. It's important to name the discretization so it's clear how it was created. Click Discretize. Your discretization of the Andreas Canyon watershed should look like this image. Notice that Agua has added 2 additional feature classes to your table of contents, streams and plains, that are identified with the discretization name. Also notice that the upland plains at the top of each channel are roughly the same size and should each represent about 2.49% of the total watershed area. And notice that Agua has included in the discretization the 2 internal pour points identified using the VARS feature class, the USGS stream gauge at the Forest Service boundary and at the day use area. Now that the Andreas Canyon watershed has been discretized, the next video will demonstrate how to parameterize it for the pre-fire conditions. This video follows the Agua mountain fire tutorial. Agua video number 2 shows how to install Agua, how to download the tutorial and GIS data from the Agua website, and provides some background on the mountain fire. The mountain fire tutorial demonstrates how to use Agua to evaluate the hydrologic effects of land cover change, in this case from fire, using the burn severity tool and a burn severity map. You'll run Agua with the Kinneros 2 hydrologic model before and after the fire, and then view the resulting changes to runoff, peak flow, and sediment yield. This tutorial is using Agua version 10.7-3.9.5.2279, ArcGIS version 10.7.1, and the 2019 version of the Introduction to Agua for Bare Scenarios Mountain Fire tutorial. You can use any version of ArcGIS with this tutorial as long as you download the correct version of Agua from the Agua website.